So let's look at this concept of a force pair, right? Remember that Newton's third law says that if A exerts a force on B, then B exerts a force back on A. And the force that A exerts on B is equal and opposite to the force B exerts on A. So the concept of the force pair is that they are never on the same object. Careful, they are never on the same object. So if two forces on one object are equal to each other, they are not a Newton's third law force pair. They may be equal to each other because of coincidence, or they may be equal to each other because of Newton's second law, but they are never equal to each other. They are never automatically equal to each other by Newton's third law. Newton's third law says that there's always a pair of forces that must be equal to each other, but they're never on the same body. Okay, so let's think about another situation. Let's take a bunny rabbit sitting on a slope. All right. I am terrible at art, I know. Okay, bunny rabbit on a ramp, right? Your typical object on a ramp. And let's just look at a free body diagram of the bunny. Free body diagram of the bunny. So the free body diagram of the bunny, you got to go through all your forces, Fn, Fg, Ff, etc. Okay, so it's sitting still. Let's say the bunny rabbit's sitting still on a slope. Don't know why somebody left it there, but okay. So, is there gravitational force on the bunny? Yes, there's there's a gravitational force on the bunny, Fg. So I'm going to assume a dot. Approximate the bunny as a dot. Okay. Is there a normal force on the bunny? Yes, the bunny is on a surface. So the normal force is perpendicular to the surface, so Fn. Is there a spring or a string attached to the bunny? No, I guess we could have put a leash on it, but there is not. So there is no spring or string. Is there a frictional force on the bunny? Yes, there must be a frictional force. Otherwise, the bunny would be sliding down the slope. It would be on a ride. But the bunny is sitting still, so that means there must be a frictional force. And what is the direction of the frictional force? The frictional force is keeping the bunny from going down the slope. It's always parallel to the surfaces of contact, is parallel to the contact between the bunny and the slope. So there's a frictional force up the slope, right? Perpendicular to the normal force. Are there any other forces on the bunny? Is there any additional thing touching the bunny that we haven't accounted for through our list of 5 standard forces? And no, there's nothing additional touching the bunny. So this is a correct free body diagram of the bunny. So now, which of these forces is equal due to Newton's third law pair? Well, the answer is none, because the third law pair is always, the pair is always on some other object. Does each of these forces have a Newton's third law pair? And the answer is yes, it must, because a force comes from another object. A force always comes from another object. So if an object exerts a force on the bunny must exert a force back on the object. So each of these forces has a third law pair. It's just not on the bunny. So, for example, what is the Newton's third law pair for the normal force? The normal force is the force of the ramp on the bunny, force of A on B. So all you do is you reverse the words, and so the third law pair is the force of the bunny on the ramp. So let's go ahead and just draw we don't have to do this in a typical problem solving, but let's just draw a free body diagram of the ramp. So there must be a force that the bunny exerts on the ramp. It's a normal force. And we'll just call this F normal bunny on ramp, B on R. And this is F normal ramp on bunny, R on B. If R exerts a force on B, then B must exert a force on R. So those two forces are equal and opposite according to Newton's third law. Okay, so what about the frictional force on the bunny? What about the frictional force on the bunny? Does the frictional force have a third law pair? Yes, it must. The frictional force, it's on the ramp on the bunny. It's still the ramp on the bunny, right? So there's a frictional force of the ramp on the bunny. It's different from the normal force, but it's still from the ramp on the bunny. and that is upwards. So what is the third law of pair? Well, the bunny must exert a frictional force back on the ramp in the opposite direction. So the bunny is exerting a frictional force, bunny on ramp. Sorry, that's a little hard to read, but that's F, frictional force, B on R. Okay, so the two forces that are the two forces that are circled for the bunny are equal and opposite to the two forces that are circled for the ramp by Newton's third law. What about the gravitational force? Where's the Newton's third law pair for the gravitational force? Well, what is the gravitational force? The gravitational force is the force. What is the gravitational force? It's the force that the Earth exerts on the bunny. So what is the third law pair? How do you figure out what the third law pair is? You simply switch places of the two objects. If the gravitational force, if the bunny's weight is due to the gravitational force, which is the force that the Earth exerts on the bunny, then the equal and opposite force, the third law pair, must be the force that the bunny exerts on the Earth. Wait, what? Does the bunny exert a force on the Earth? Let's just put the Earth down here. The bunny isn't actually floating, right? The ramp is on the Earth, but free body diagrams. These are all free body diagrams. Free body diagram, and free body diagram of the Earth. I'll undo those so we can see the Earth. So the Earth pulls the bunny down. The bunny must pull the Earth up. And indeed it does. And there must be a gravitational force that the bunny exerts on the Earth. B on E. If there is a gravitational force that the Earth exerts on the bunny, then by Newton's third law, there must be a gravitational force that the bunny exerts on the Earth. And you say, really? Does the bunny exert a gravitational force on the Earth? And the answer is yes. Don't forget what gravitational force is. Gravitational force is the force between any two masses. All masses exert forces on each other. It's just that the Earth is so much of a bigger mass that we notice that one, and we don't notice the other ones because they're so small. So the bunny indeed exerts a gravitational force on the Earth, pulling it upwards. And then, of course, why don't we notice that? The bunny doesn't move the Earth, but the Earth moves the bunny, right? If we drop the bunny, it moves. Why don't we notice the force the bunny exerts on the Earth? Because the Earth is so large. Also because there's a bunny on the other side of the Earth in China that is pulling in the other direction, but that's besides the point. But these are all third law pairs. Okay, let's make sure we understand that these are third law pairs. These two are third law pairs. These two are third law pairs. And these two are third law pairs. A third law force pair, the things that are equal and opposite, are never on the same object. If the bunny exerts a force on the ramp exerts a force on the bunny. Those are two different objects.